Howdy. It might be a good time to talk a little bit about Iceland. And I really mean what I say, it's just basically a little bit. And since a while already, I'm somehow wondering what's the thing about Greenland? Because there are many glaciers, and there's like so much stuff buried beneath the ice. And for those who have seen some of my earlier videos, you probably know that I think that glaciers are lava streams made of water, which means that the mountain carrying the glacier is a volcano. But there is never any earthquake in Greenland. Nothing ever going on in Greenland. Which is in a way a bit strange. Maybe it's just so that there is nothing going on in Greenland. Who knows? But there is activity in Iceland, quite much so. And we have to see, there are also already some live stream cameras, I think, positioned and on. You can go there to wait and see when it starts, if it's at the right spot. But there is something I found today which relates to Iceland and my microwave experiments. And I think all those experiments are also found here in this Finnish copper playlist. And for those who haven't seen or have no idea what I'm talking about, is let's just watch quickly one. That's in the area, and we know for a fact now that they have that's actually from the video. But let's go to the beginning. Let's go somewhere here. So this stone has been in the microwave for some time. It turned red. There's stuff pouring out of it. It glowed. And yeah, it didn't look like this before. So now let's go on a bit. But you have seen the melt. This is how it looked before it has been in the microwave. And I found it back then very interesting because it has this yellow color. Because yeah, I'm still pondering about the sulfur, how there's so much sulfur and what's going on. And after it has been in the microwave, as you can see, it changed. It turned out to pour out stuff, which is rather black. And it's very brittle as well. And when we go to the microwave, remember? And the flames shoot up to heaven. So, I think no one really can blame me for making something up. There's like really flames shooting up to the heaven. And the stone is really melted. And that's from another video I made. From another experiment I made. Now obviously, You can see the stone is rather hot. It's yeah, it's glowing, and it has been growing. It glows and grows. There has been something. Wait, I have to. Yes, there has been something coming out. This was the stone. How it looked before it has been in the microwave. This is the stone after it has been in the microwave. So there has been something going on. Obviously. And some time ago, I have been in a very special place. So it was so special that I said that, yeah, we should probably slice this in two in order to see what is in the stone. And that's exactly the same stone you just watched. Cut in half. And it's undeniable, it's hollow. There is nothing inside. But there is this bulge on top of it. So it seems that it just heated up and gases expanded and stuff went down. Yeah, and since a while, I don't really know what to do because I know stuff which I am probably not supposed to know. The reason, uh, that's the reason why I didn't share them yet. Yeah, it's very interesting. But let me just continue now. One day I will talk about where I've been and what was going on, but I learned some things. And one of them is that it is very important to know more about aluminium silicate. Aluminium silicate is a name commonly applied to chemical compounds which are derived from aluminium oxide, Al2O3, and silicon dioxide, SiO2, which may be anhydrous or hydrated, naturally occurring as minerals or synthetic. It is known as the E number E559. That's in your food. You eat it. Andalusite, kyanite, and sillimanite manite are the principal aluminium silicate minerals. The triple point of the three polymorphs is located at a temperature of 500 degrees and a pressure of 0.4 GPa. These three minerals are commonly used as index minerals in metamorphic rocks. So, let's go on to the next one. I'm trying to somehow get this together. But anyway, we have aluminium and silica. Now we go basically back to Iceland. Volcanic soils of Iceland. I found this paper and it's very interesting. The primary materials of all Icelandic soils are volcanic in origin. And most of the soils are classified as andosols. And yeah, there has been several words I really had to Google and figure out what they really mean. What's the thing about them? And let me just see, where was it? This one here. The andosols, histic, gleic, and brown andosols, show characteristic properties of soils dominated by Andic materials with allophane contents of up to 30%. Allophane. We cannot zoom in here. It's a little bit difficult, but I hope you see the word. Allophane. Allophane. So now let's go quickly over to Science Direct and learn about allophane. I haven't heard this ever before. Allophane containing andosols are soils formed from volcanic ashes and ejecta. Related terms. Aluminium silica, clay, kaolinite. Yeah, the thing is, I know the chemical composition of the melt to some degree. And it turned out that aluminium is a very important ingredient. Essentially, it makes a rather big part of the whole melt. Aluminium. Allophane and immogolite. Allophanes form from volcanic ash materials and are major components of volcanic-derived soils. They may also be found in the clay fraction. Clay. And many non-volcanology-derived soils. Volcanic soils containing allophane usually contain significant organic matter and have low bulk densities. The silica oxide and aluminum dioxide, was it? Al2O3. Yeah, that's very important. Ratio of allophanes varies from 0.84 to nearly 2. The characteristics ratio of kaolinite aluminium is in both tetrahedral and octahedral coordination. Yes, immogolite has an almost constant SCO2L2O3 ratio of 1 and aluminium is only octahedral coordination. In octahedral coordination, while it has a little charge resulting from isomorphic substitution, immogolite can absorb substantial quantities of monovalent cations. Yeah, anyway. Amorphous materials. Occurrence in soils. Allophane and immogolite result from the rapid precipitation of soluble aluminium and silica that are released either by labile parent materials such as volcanic ash or by intense weathering of any parent material ranging from sandstone to granite. Intense weathering. What's the most intense weather thing you can imagine? I think it's a lightning bolt. It's electric. They are metastable products that form in favor of more stable crystalline minerals such as kaolinite, because SRO materials have lower surface tension and thus nucleate more rapidly in aqueous solutions. Eventually, they are replaced by the more crystalline aluminosilicate clay minerals. Yes, I tell it again. Aluminosilicate clay minerals. And as silica is weathered and leached from the soil by Fe iron and aluminium hydroxides, allophane and immogolite may begin to form immediately in an ash deposit, but increase in concentration over tens of thousands of years before declining in favor of the more crystalline minerals. Therefore, their metastable nature does not diminish their importance in soils. So, crystalline aluminosilicate clay minerals. So, I have been pondering about a bunch of things, and I have been mentioning clay many times. And I've been writing about mountain water, I have been writing about the copper and sulfur deposits or occurrences here in Finland. Yeah, in Italia, I tell it again, in Italia, for example, Solfatara, it's not Solfarata, it's Solfatara, obviously, where we have the earthquake activity in Campi Flegrei in Italy, Vesuvio. It's white, you see it from very high above when you watch satellite pictures. The Romans gathered their sulfur there. Yeah, it's a volcano, there's sulfur coming out. Yeah, many people know that. But the problem is there is no volcanoes in Finland, or no such volcanoes in Finland. But there are many mining operations which are mining either copper or sulfides, many different kinds of, because you need sulfur in order to get a sulfide. Sulfur mixed with something else gets you some sulfide. You don't get a sulfide without a sulfur. Yeah, and many other things I've been pondering about. And also clay. And now it seems to me, not only is this black stuff which is pouring out of these rocks, or this rock here, there's another one. It seems that this material is basically clay, just without water. Because it not only looks like it would be very brittle, it is very brittle. It's kind of foam. So if you crush it, and it wouldn't take long in order to crush this little piece, because it's like it just falls apart into very small pieces, into dust, basically. So what's clay after all? It's dust with water. So I probably created with my microwave experiments dry clay or raw clay. My microwave experiments, they are basically showing something big on a very small scale. It's electromagnetic radiation on the microwave wavelength, 12.23 centimeters. And it's basically induced energy, induced electromagnetic energy. There is electricity going on in the rock. Yeah, what a nice drawing. Now we have to make a connection here too. Electricity is going in, and there are parts of the materials which are conducting the electricity very well, and other parts they don't. They exhibit a high resistivity, and so they start to heat up, and they heat up the whole stone, and then there's, I think, many chemical reactions going on. And also transmutations of elements, as described by Edo Kahl in its structured atom theory. And the result is that through that induced energy, there is stuff pouring out, which is basically, or it seems like, it's quite much clay. It's just the dry version of it. So we have Earth, which is powered by the sun via the Birkeland currents which flow through Earth, which are creating the heat in the center. Let me search your picture quickly. So the picture I'm going to show you is from my mountain water paper. I will put a link below. You can go and check it out. Then we just scroll down until, yeah, here is actually Campi Flegrei. I have been just talking about it. Solfatara, the sulfur crater, that's where it got its name from. White rivers, not yet, pH, no. Here it is. So I think at the Earth's core is a plasmoid. And all these bots, that's a laboratory plasmoid, or a picture from a laboratory made plasmoid. It's kind of plasma ball, maybe a better version of what you can buy in a shop. But anyway, these parts are where we find volcanoes, possibly. I hope your imagination is good enough that you can somehow imagine that there will be pathways which go to the surface because everything is connected. We have also here in the same paper, in order to show you what I mean about the connections, we have to scroll up a bit. Sorry for the scrolling. I think it's up there somewhere. There we have the jewel antennas. Charge accumulates on peaks. And where we have those spines, there we have volcanoes. And I think they are connected. They go way down to the plasmoid, which creates the heat, which creates the elements, or transmutates the elements, which keeps our atmosphere in place, which goes out until to the magnetosphere. So, it seems that it is possible to create clay in a microwave. Induced electric currents into the pebble in the microwave, or scaling it up, induced into Earth. Where was it once? No, here. And there are different kinds of volcanoes with different kinds of lavas and ejecta in general. And I just happened to look for Iceland since it's in the news. And it's striking how many similarities I found between my melt and the lava from Iceland. And if you think about the same process going on a few hundred meters or kilometers beneath our feet, and there is the same material which I created in my microwave, which is very brittle. Yeah, it could be created down there, but since it's very brittle, it will break down into the smallest pieces it's made of. Then we get clay, and it gets intermixed with water, and once it eventually starts to pour on the surface, now we just have to figure out a few other things. But I think I created clay in my microwave. It's just without the water. And of course, as you know, hopefully, there are many different kinds of clays. But maybe it could be that aluminium is one very important thing in the whole. And it may be, like I have been talking about, the auroras touching the ground and probably brought the copper to Earth. In this way, it came from above and not from below. And I'm still wondering what was the thing which made it. You know, there is sulfur associated to the copper. But there must be something else too, maybe. I don't know. But it seems that aluminium is alloyed argon gas. Maybe. Maybe argon in its metallic version is aluminium. But the whole thing is still under investigation. There would have been so many things more I would like to show you about this whole topic. Many, many, many other things. But let's leave it here. That's already a rather long video. But I think, in a way, I finally figured out what clay is. Ah yeah, let me show you just still one thing. Space.com. Yesterday, they brought back Smithsonian debuts one of the first display of asteroid Bennu sample brought back by Osiris-Rex. It was sort of the Goldilocks effect. This one was too big, that one was a little too small, and they found one that was just right. Alright, 3rd of November. Yeah, it was a special day yesterday. It was my birthday, there was Jupiter alignment, and I had an epiphany about clay. Didn't happen ever to me in my whole life to blow my mind by myself at my birthday. But it happened. Yes, it didn't cost a thing. But anyway, let's check it out. Where was the thing I wanted to show you? Because I find it very interesting. Yeah, there's a lot of commercials here. It's really annoying to find the text, but let's just read this segment here. A CT computer tomographic scan of the fragment labeled by NASA scientists the Johnson Space Center in Houston as ORX 800027/0 showed that the stone is made up of dozens of smaller rocks that were fragments cemented back together, and that the entire piece was heavily altered by water, producing clays, iron oxides, iron sulfides, and carbonates as its major minerals along with carbon. I have to point out clay. Now let's draw it better. Clay, iron, oxides. Yeah, there's water obviously too. I don't know what they mean with heavily altered by water, but anyway. And iron sulfides. You don't get sulfides without the sulfur. And I'm very interested is there, or how much aluminium is there? Will they ever tell? I think there is. But anyway, and titanium maybe too. But yeah, this was just I just wanted to tell you something about clay because it's very fascinating. Yes, I think I'll leave it here. Now that's a very amazing topic. Yes, thanks. Bye.